Welcome to my logic simulator of an 8-bit computer. I'm using this tool from Cols.net, GateSim, and the design is inspired by Harry Potter's Relay Computer. His website is here. Okay, let's see my instructions. I have the load immediate. We can see if the first bit is 0 and 1, we know that it's the load immediate. And it takes the value in D1, 2 and 3 and puts it into the A, C and B. Or C and B. And there's the ALU, which is 1, 0, 1, 0. Then we know it's the ALU, which takes the... it has some functions. Here we can set function 1, 0, 1 and 2. And it takes the value from the ALU and to put it into the D. So I have an add and I have a compare, which I use. I also have two other one, and an or if I want. But this is what I'm using here. And then we have the store, which takes the value from the address 0 and 1, so from the memory, and it saves the value from what's in the D registry and saves it into the addresses, the first bits here, 2-bit. So we have 4 addresses in the main memory that we can put data in. Okay. Then we have the move, where we can move from D and A onto the C or D. We have a load, which loads from the memory. It's very much like the store, but this is the opposite way. And we load from the memory and puts it into the C or B. We have an increment. We can take the B and the C and increment it and save it back to A or D. And then we have a go-to, which just changes the PC registry to the value in D1, 2, 3 and 4. We have a branch, which branch to the value in D1, 2, 3 and 4 if the ALU register, the register that connected to ALU, is only ones. All 8 bits is 1. Then there is a halt also, so stops the computer. Okay, let's look at the program. So here you can see the multiplication program that multiplied 2 by 5. So the first instruction is just setting 0, 0, 0, 0. It doesn't do anything. Then the next is load immediate, load 0 to A. Okay. Set this nothing into the A. Then we start move A to C, which is 0 of course, into the C. Increment the C to A, so increment the C, which now is 1, and save it back to the A. Load 1 to B, then you have an ALU compare, whether C is the same as B, and we can see C is 0, and B is 1, so it's false. Load 5 into B, and load from the address 0, 0 to C, which is 0. There's nothing in it. We know that because there's nothing there. And then the ALU sums it together and put it into the D. And we know that the C is 0 and B is 5, so D is get 5. Then we store the value in D back to the 0, 0 address. So now we have 5 stored where there was nothing in the start. Now we have 5 stored there. Then we check the if branch. If is true, we go to the 12, but we know it's false. So we go up to, then we go to the 2 here, and then we are back here, and now we are in time 2. When we know move A to C, and we know what A is set to 1 here, so now C is 1. Increment C to A, so now A is 2. And load 1 to B, and then we compare C and B. We know that C is 1 and B is 1, and now it's true. Then we load 5 to B, and we load from the 0, 0 address into C, and we know that is 5 because that's what we stored last time. So, and then we ALU B and C, and then we get 10 and store it back to the D registry. And then we store the back to the main memory at the same 00 address, and now we have 10 stored in the main memory. And we check the if, and now it's true, so it jumps to the halt and stops. Okay, so the next video is gonna show the program in the simulator.